Hello everybody, how is everybody doing? In this lecture, we will be discussing projection on an inclined plane, which would prove itself to be very useful in writing different competitive exams. Let's begin with the concept here. There are two kinds of projections that you will see. One is projection up an inclined plane, and you're in the second case projecting from the top of the inclined plane towards down. So these are the two different ways you can throw a projectile. This is completely different when compared to the ground to ground projection that you do, where all your equations that you've learned are equal to u square sine 2 theta divided by g v square, or maybe you have the equation for maximum height u square sine square theta divided by 2g. All of these equations can be used, but the interesting part here is, number one, none of those equations can be used here. Number two, it's possible to derive an expression for range, time of flight, and the other related quantities for projections on an inclined plane. So let's begin with the first topic, which is projection up an inclined plane. My dear friends, let's think about an inclined plane. So here we have an incline, and maybe I'll just flip it so that it looks like an incline that we want, and may color it too. So that's the inclined plane we are talking about. Let me also think about a coordinate system that is attached with this inclined plane. So here is our x-axis, and a y-axis can also be thought of in the same manner, right? So that's my y-axis. I'll just place it here. This is our y-axis. I shall name it y and x. Okay. Let's assume that the angle of inclination is beta. I shall mark this angle and call that beta. Consider a projectile that is thrown from the bottom of the inclined plane at an angle alpha. So let's say that this angle is alpha. What happens now is that this particular projectile will fly up, right? It will fly up and fall down to the projectile's incline. It will fall on the incline, and we are interested in finding the amount of time it takes in order to go there. For that, let's write down all possible initial velocity, final velocity, and maybe the acceleration due to gravity and all of that along the new found x and y axis. So we have ux, right? Initial velocity along the x direction. The initial velocity along the x direction, dear friends, is u cos of alpha minus beta, because that is initial velocity u. Ux is u cos of alpha minus beta, and then you have uy, the initial velocity along the y direction, which is u sine alpha minus beta. In addition to that, you can also resolve acceleration due to gravity along the new x and y axis. Let us do that. Watch. We have the acceleration due to gravity pointing in the downward direction, irrespective of how your inclined plane is, and let me call that g. Now g can be resolved into a direction perpendicular to the inclined plane, which is going to be in this direction. Another component would be along the direction of the incline. So if angle of inclination is beta, then this angle, dear friends, is also going to be beta. If you resolve it, this is g cos beta, and the other component is g sin beta. Having said that, it is easier now to write down what is the acceleration along the x direction. Acceleration along the x direction is minus g sin beta, right? And what is the acceleration along the y direction? Acceleration along the y direction is minus g cos beta. The reason why I put minus signs is because this vector g sin beta is in the opposite direction to that of positive x axis, and hence both of these get negative signs because of similar reasons. Having said that, let us talk about the time of flight to begin with. Now, how do you calculate the time of flight? Time of flight is the time taken for the y coordinate of the projectile to become zero from zero. So the y coordinate increases, 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 becomes maximum, and then it decreases, 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 it becomes zero. So that's what's happening. Let us apply the equation s is equal to ut plus half at square along the y-axis. If you do that, we have sy equal to uy into t plus half ay into t square, my dear friends. If you're talking about the displacement becoming zero, then it is the amount of time that it takes for the projectile to land back on the incline. That's what is called time of flight. So instead of small t, we will employ capital T representing the time of flight. So uy is u sine of alpha minus beta multiplied by capital T plus half into minus. Along the y-axis, the acceleration is minus g cos beta multiplied by t square. Let's transfer the term here. What do you get? You get g cos beta divided by 2 into t square becomes equal to u sine alpha minus beta into t. The t's get cancelled. So we have one time of flight t equal to u sine alpha minus beta divided by g cos beta. You also have a 2 in the numerator because this goes up. That equation is the equation for time of flight, dear friends. That's the equation for time of flight when you are throwing an object up the inclined plane. Having said that, we will discuss about how to calculate the range now. It's a very important thing to note that range essentially is being measured along the inclined plane. So if you think about it, this is what is called range. But instead of calculating r, we can calculate the total horizontal distance the projectile has traveled, and the total horizontal distance the projectile has traveled is going to be this. And because this is r and angle here is still beta, the angle here is still beta, the length starting from here to there can be written as r cos beta. The reason why I talk about horizontal is because it's easier to achieve an expression for range. Let's do that. We have r cos beta is equal to horizontal component of velocity is u sine beta, u sine alpha minus beta. That's the it's not sine, I'm really sorry, it's u along the horizontal we are talking about. So u cos alpha would be the initial velocity along the horizontal. I shall write u cos alpha multiplied by the time of flight. This is simply displacement is equal to velocity into time formula. The reason why I'm able to apply this formula along the horizontal is because there is no acceleration along the horizontal. Having said that, what does r cos beta become equal to? R cos beta becomes equal to u cos alpha multiplied by t, which is 2u sine of alpha minus beta divided by g cos beta. And what does r become equal to? R, dear friends, becomes equal to 2 multiplied by u into u is u square, and then you have cos alpha multiplied by sine beta multiplied by sine alpha minus beta divided by, we've set this cos beta down, so we have g cos square beta. I don't want to leave this expression here. Maybe we can convert this particular equation this way. We have 2 times cos A sine B. That's a trigonometric identity that I'm trying to write. Okay, 2 times cos A multiplied by sine B would be equal to sine of A plus B minus sine of A minus B. So when you simplify sine of a plus b, which is sine a cos b plus cos a sine b, and this is sine a cos b minus cos a sine b, you will definitely get 2 cos a sine b. Let's use that equation and write cos alpha and sine of alpha minus beta in terms of sine a plus b minus sine a minus b. What do you get? R becomes equal to, there is 2 cos alpha sine alpha minus beta being absorbed in here. All you're remaining with is u square. A plus b. A here is alpha and b is alpha minus beta. If you add both of them, you will get 2 times alpha minus beta. Of course, sine. You have u square sine 2 alpha minus beta minus sine of a minus b, alpha minus alpha plus beta would be just beta divided by g cos squared beta. That is the equation which we have got to calculate the range. Let me put a box there so that you will remember it before you go to the exam hall. Okay, so that's the expression for range for a projection up an inclined plane. Now you would be wondering, what is the answer? What is the expression for range when you shoot a projectile from the top of the inclined plane in the downward direction? Then let's find out what happens. We will draw another diagram. We are talking about projection down an inclined plane this time. We will again think about an inclined plane, and this time let's color it. It's fun to color, so maybe we will think about an inclined plane which looks like this. Every other thing remains the same. That angle is beta. Let me draw the horizontal from the point of projection. Here is the horizontal from the point of projection, and other vectors like initial velocity, I'm going to draw this way. That's the initial velocity vector, colored it blue. We will also want to draw our x and y axis. Let's do that. X axis could be in this direction. That's the x axis, dear friends. And y axis would be somewhere the other way. Right? It's not visible, right? So this is fine. And y axis can be thought of a vector like this, or maybe just an axis like that. Having said that, let's call this angle alpha. We have called that angle beta anyway. This is your y axis, that's your x axis. U is the initial velocity. What do you think is ux, my friends? Don't you think ux is, because this is alpha, that's also going to be, that's going to be beta. They are alternate interior angles. Ux is going to be u cos of alpha plus beta, and uy is going to be u sine alpha plus beta. That's going to be initial velocity. And what is going to be the acceleration due to gravity? That's g. Along the x direction, it's like that, and along the y direction, it's like this. And obviously, here the angle is beta. Acceleration along the x axis can now be written equal to g sine beta, and along the y direction is minus g cos beta. Well, you do the exact same thing that we did in the previous situation. The answer for time of flight you will obtain is 2u sine of alpha plus beta divided by g cos beta. That's the expression for time of flight you will obtain, right? That's the expression for time of flight you will obtain for projection from top of the inclined plane. And alpha, beta are the angles you need to know. They are all measured from the horizontal. You need to be aware of that. If you similarly simplify for range, the range will turn out to be u square sine of 2 alpha plus beta plus sine beta divided by g cos square beta. That's the answer for range you will get. In case you find it difficult to derive these expressions yourself, write to me on my email ID being displayed on the screen. If you need worksheets to solve based on this particular topic, then please mail me on my email ID. I'd be happy to share with you. Let's look at the most important points of this lecture. I have one little thing to tell you. The acceleration along the horizontal is always zero. The Earth's gravity pulls everything down. There is no component of that force in the horizontal. If there is no force, there is no acceleration. If there is no acceleration, there is no change in velocity along the horizontal. So we need to understand that u cos theta, which is basically the horizontal component, is always a constant, right? That's one thing I'd like to tell you. The other very important idea that I'd like to convey with you to you is, at what angle should you project a projectile on an inclined plane for its range to be maximum? Let's find out. For projection up an inclined plane, you know that the formula for range is u square sine 2 alpha plus, 2 alpha minus beta minus sine beta is all you have, right? Divided by g cos square beta. You don't have to bother about beta because beta is the angle of inclination. There is nothing you can do about it. But alpha is the angle of projection. You can always change that. So what should be the angle alpha for the range on an inclined plane to be maximum? Let's answer that question. For range to be maximum, you will have to have this guy being maximum. That means sine of 2 alpha minus beta should become equal to 1 because that's the maximum value of sine function. What does 2 alpha minus beta become equal to? It becomes equal to pi by 2. It's 90 degree. Now, what is 2 alpha equal to? It's pi by 2 plus beta, my dear friends. What do you think is alpha? It's pi by 4 plus beta. That's the answer for, that's the answer for maximum range. That means if there is an inclined plane, okay, something of that sort, and you want to project, let's say that this angle is 30 degree, you want to project at an angle such that the range is maximum, then the answer should be 45 plus beta by 2. Beta is 30, 30 by 2 is 15, 45 plus 15 is going to be 60 degree. You will have to throw it at an angle of 60 degree in order for the range to be maximum. And I want you to do the maximum range for the case where you throw a projectile down the inclined plane. Your answers in the comment, please. Thank you so much. Have a nice learning experience. I'll see you in the next video.